Okay, so some of the terms that I'm going to cover this morning. Asset is any script or material or anything that goes into a project that Unity is going to use. So if I write a piece of code, that is an asset. If I develop a 3D model, that is an asset. If I download a texture off of the internet to put on my 3D model, that is an asset. And the assets live within a special folder under the Unity project folder. And here in a minute, I'll go over what that project folder structure looks like. Everything that's under the assets folder inside of our project folder is considered an asset. Unity is actually constantly going through that assets folder, looking at every file in there to see if it's something that needs to incorporate. So it's useful for your workflow to have the assets folder open, and as I'm accumulating new assets, I can just drop them into that folder. The next time I go to Unity, Unity's going to automatically incorporate that into the project. So that you don't have to import anything into Unity. If Unity knows how to use it, you put it in the asset folder, Unity's going to find it. It's sweet. Yeah.
So our assets, are they developed outside of Unity and then imported into Unity? But,
yep.
Okay, so how does Unity, like its game mechanics and the physics behind it, what's the difference between an asset of Unity and an asset you import into Unity?
They're the same thing.
Okay. So those are just special assets then?
Well, there's a limit to what kind of assets it can work with, right? So there's different 3D formats. I'm trying to decide if this is a bit of a digression, but since you asked. All right, so there's, got my assets folder, right? And then I may have other folders inside of this for textures or models or scripts or something like that. And then out here on the internet, let's say I'm a developer, I'm a programmer, I'm a designer, not a 3D modeler. I know how it's done, but I'm not really very good at it. So a lot of times I'll go out and I'll look for my 3D models either as an FBX or an OBJ format. There's also 3ds and Blend. They're very popular, right? And I can import those into my asset folder. And when I mean import, I mean just copy them over to that folder, right? So it's not like I have to actually import something into that folder. I just copy it over to this assets folder. When I come back over to Unity, it's going to look through this, and this view right here is my assets folder. Anything that it finds that it knows what to do with, it's just going to automatically incorporate that into the project. That doesn't mean that it's going to be put into the scene. It's just going to be available in the project. And are we at the point where we're talking about the difference between projects and scenes? Yeah, so, okay, so a scene is a collection of assets that should work together in sort of a scenario, in sort of one setting. And then a project is all of the assets and all of the scenes that are available over the entire game. In a video game analogy, let's say I've got a game that's got multiple different levels on it. Each level is a scene. The entire game is built on top of the project. So I may have a project called, Battlefield 1942 or something like that, right? And inside of my project, Battlefield 1942, I'll have a scene that's called Storming the Beach, or Baron von Ravenclaw's castle, or something, right? Destroying the lab where the Nazi zombie soldiers are being built or something. So that's the difference between a project and a scene. And if I drop assets into my project, it doesn't necessarily mean they're going to be used in the scene, just that they're available to be used in the scene. GameObject is a very important term when it comes to Unity. Unity is a very object-oriented environment. The programming environment is very object-oriented, and the game engine itself is very object-oriented. Does everybody know what I mean by object orientation? You get an idea? It's basically a piece of data that can do stuff, That's probably the simplest, most elemental. It's a piece of data that can do stuff, right? So everything in the scene is based off of a type of object called a game object. Everything in my scene is a game object with other stuff sort of attached to it. So like over here, I've got, this is a default scene, and I've got just a blank, untitled scene opened in my project. And it gives me a main camera and a directional light. Now those are two completely different things. One's a camera, one's a light, right? But at the top of, well, when I select one of these things, I come over here to the inspector, the top one of these things shows me that it's a game object, and this is the game object information. Everything that's in my scene has this game object sort of identity to it, which means it actually resides at a place. It has a location, whether or not it's something that I can see, whether or not it's something that I can interact with, or even am aware that it's there. If it's in the scene, it's got a position, it's got a location, it's got this sort of identity to it. Now it may have other stuff attached to it. So like my camera is a game object with a camera attached to it. My light is a game object with a light attached to it. Then prefabs. A prefab is a special sort of collection of data and assets that I can put into my folder. And I can have multiple game objects in it, I can have multiple different components in it, I can have scripts in it, and then what it allows me to do is I can drop this assemblage into my scene and just have it work. I don't have to, if I do it right, I don't have to do anything to it to make it work. I just drop it in the scene, and it should have as much stuff as it needs in it in order for it to do its function. I know it's sounding very vague, but that's exactly what's going on. Whether or not it does have everything it needs is based upon the person that built it. So if the person that actually put the prefab together, and a prefab is something that you as a designer have to, you either have to find it or you have to put it together yourself. And then the last thing that has a specific sort of definition in this context is behavior. So early when Unity was being developed, the scripts that I attached to objects were not called scripts, they were called behaviors. And in fact, the class that all of the scripts that we're going to work with, the class that they're extended from, is called a mono behavior, because they used an environment called monodevelop to compile their behaviors. So they call that object a mono behavior, and it's since been just shortened to behavior. But if I put a script on an object that makes it do something, makes it spin, makes it throb, makes it talk to something else, makes it shoot, makes it explode, whatever it makes it do, that's the behavior of that script. So what this means is, because Unity can work with all these different asset types and all these different 3D models and stuff, I don't have to write the code to get it to load the 3D model. I just have to concentrate on the behavior that I want that 3D model to have. Is it a car? Do I want it to drive? All I have to do is make it drive. I don't have to construct the car in Unity. In fact, Unity doesn't have very many tools at all for constructing different types of prefabs. The 3D models and the materials and the sound effects, they're usually all generated in some sort of external application. So this is a very high-level architecture of what Unity, and some of it I'm maybe about to repeat myself. So I have external tools that I'm using to create my assets. So I have Visual Studio that I use to write my behaviors. I have Blender or 3D Studio Max that I use to create my 3D models, or maybe not me, somebody that's working for me will make my 3D models for me. And then I can use the Adobe Suite to make my materials, make my animations, make my sound effects. All of that stuff goes into my projects assets folder that holds my behaviors, my scripts, my models, everything that my project is going to need. That information goes back and forth between the editors. So the editor, this thing right here, is called the editor. So when I'm referring to the editor, I'm talking about this graphical interface here and all the different components of that. It's constantly looking at the projects folder, and it's constantly updating itself. So another benefit of prefabs that I didn't go over is if I have something in my projects folder that I move over to my scene, and then I update that from some sort of external tool. Let's say I've got a 3D model. Oh, my 3D model needs to be fixed. I hop back over here to my external tool, I open up 3D Studio, I fix my model, I save it back to my project folder. When I come back to Unity, my new model is going to be incorporated into my scene. So it just all sort of automatically updates itself as I update the resources that it's using. And that's beneficial in large projects because you may have somebody who's a designer that knows, I want this 3D model to take up this amount of space, and they're using really crude geometry to block out that space. So I can export that out and give it to my talented 3D modeler and say, here's how big I want this thing to be and generally the shape I want it to be, make it look good. So he goes and he takes that and he makes it look good. Meanwhile, I'm designing the game around this very crude sort of version of the model. When he gets the 3D model done, I incorporate it back into my project. Voila, the beauty comes into the scene and it sort of updates itself. It's a very nice workflow. The editor talks back and forth between what's called the engine and then different platform compilers. So this is the Unity editor. The Unity engine is constantly running, and that's the actual game engine itself. And it is an engine. It runs on a cycle. And it's constantly trying to do this, whatever operations, as quickly as it can. The engine handles physics, lighting, script execution, all that sort of stuff. And then if I need to compile my application in some sort of platform, maybe this is going to be an Xbox One game, maybe it's going to be an Android application. What we're going to be doing this afternoon will be an Android application. So I have to have Android compilers, the system has to have Java on it, I have to have Android Studio, the Android SDK, and none of that stuff is included in Unity. Unity will tell you where to go get it if you don't have it, but none of that is included in Unity, and Unity uses those external resources to compile Android applications. This is my typical workflow. I open up the editor, I realize I need some assets, I'll open up an external editor, probably watch some YouTube tutorials, and eventually I'll get around to writing some code, constructing the scene, and then test or deploy it. And then this cycle goes over and over and over. My typical workflow, I bounce back and forth between designing the scene in the editor, writing code in Visual Studio, and because it's such a complicated environment, I'm almost always trying to find some sort of tutorials, trying to find some sort of reference. And we're getting to a point where there's actually a lot of information out there. Which is good. Because nobody likes to learn things by trial and error. Okay, yeah, so I create the project folder, everything goes into the project folder. You're going to see a lot of files called assets or meta. You'll see a lot of meta files. So for every project, every folder in my assets folder, every file in my assets folder, I will see another file that's got the same name as whatever the folder is or whatever the file name is, .meta. And what that is that's those are files that Unity creates automatically, and it's information about that file. So if I here is a sprite. It's a graphic image. It came out of the Vuforia, out of the MergeCube SDK actually, and it's got information up here in the inspector about what kind of texture it is, what is the resolution of it, how do I want to treat the opacity, is it a PNG, is it a JPEG, how big do I want it to be. All of this information is stored in the meta file that Unity creates about that. So if I make changes to this in the editor, and I may change the way it looks, and I may change the way it works, I'm not actually changing that file. I'm changing the meta file about that file, which is sort of informing Unity about the changes that it needs to make when it incorporates that into the build. But I'm not actually changing that file. Okay, I think I've probably gone over this. All right, the editor. Here we are. Now, this is not the way it may look when you first open it up and you install it. This is the default layout. And so the first time you start up Unity, this is probably the layout that you're going to see. Over here in this window called the hierarchy, what's the next thing over here? Okay, so over here in this window is called the hierarchy. I see all of the objects that are in my current scene. Right, so this is where I put my scene together, and I can have multiple scenes loaded at the same time if I wanted to, but that's not something we're probably going to get into today. All of my lights, all of my game objects, and their relationships to each other are going to be listed over here in the hierarchy. The project window shows me all of the folders under my asset folder, and then this is the content of that folder. So if I come over here and click on one of these other folders, my content window updates to show me what's inside that folder. Then I can select that, and I'll see it show up in the inspector, which, where'd my mouse go? The project tab, we talked about that. Here's the inspector. Okay, so the inspector is probably going to be the tab that you use the most. The inspector automatically changes itself and updates itself to whatever I currently have selected. So I select my main camera in my inspector, it shows me all my camera stuff. Same thing with my light. And if I create a cube or just create some sort of object, my inspector tells me everything about that cube. One thing, all right, before we get to the game tab, one thing that's important about the inspector is I need to be aware of, am I looking at something in my project folder or am I looking at something in my scene folder? Because my inspector is not going to tell me which one I'm looking at. As an operator of this interface, I have to sort of be aware that I've selected something in my project folder, and that's what my inspector is showing me, versus I've selected something in my scene, and that's what my inspector is showing me. Because if I make the change, in the scene, it may or may not update that asset in the project folder. If I make a change in the project folder, if it's a prefab, then it'll make the corresponding change in the scene. But I may have an instance where I've got my prefab over here, and Unity will let me make instance after instance after instance after instance of that prefab, and each one of these instances are slightly different from each other. And so that's when it becomes important to keep track of, am I making changes to the base, to the parent, or am I making changes to all of the instantiated copies of this? And you just have to keep up with it. Okay, the game tab. This is what the camera is seeing. So if I come over here to my game tab, I look at my scene, and I see where my camera is, I see where my light is, I see where my cube is. The game tab is showing me how the game is going to look when it's played through the camera's view. Every Unity scene needs to have a camera of some type. because the camera is how the game engine gets the information out of the scene and puts it on the screen. So it has to have a camera in there. If there's no camera, this would just be a black screen, and I'd get a message saying, hey, you should add a camera if you want to see anything. So when I switch over to the game tab, it automatically is showing me what my main camera is seeing. Now I can have multiple cameras in my scene, and I can have cameras that do things other than just put imagery in a window. I could have a game that actually has multiple windows, multiple cameras, each camera going to a different window, or I can have cameras that are doing things like rendering a part of the scene and then using what it sees as a texture on another material. Say if I want to make a portal into another space, or if I want to make a mirror. A lot of times mirrors are done by putting a camera facing out from the wall and then taking what that camera sees, turning it into a texture and applying it to the mirror. It's just a trick. It's just a trick. But you can have multiple cameras, you've got to have at least one, is I guess the point of all that. I've got these little VCR controls over here at the top. I bet that's the next slide. Oh, the console tab. The console tab is, it's one of my most prominent tabs. I see a lot of people, and a lot of my students will actually close the console tab, or they'll hide it or something. And that's not a good practice as far as I'm concerned, especially if we're developing a lot of scripts and you're trying to figure something out. You want to keep the console tab prominent, because it will show you all sorts of warnings and errors. And see, look, I haven't even done anything, and I've got 26 warnings already. Most of them are coming out of MergeCube. That's fine. MergeCube is a third-party piece of software. I can't expect it to be 100% perfect. So MergeCube is giving me 26 warnings. But you know what you can do with warnings? You can safely ignore them, because they're only warnings.
So warnings, errors, are there other?
Warnings, errors, and messages.
Got it.
Right. So if I write a debug statement in my code because I want to see a return value, that debug statement will show up here in the console. And that's probably one of the weak points of Unity, is that I'm not going to go into that. Debugging code is kind of a thing in and of itself in Unity. A lot of times you have to resort to writing debug statements to the console to get information out of your code. There is a way to attach Visual Studio and use Visual Studio's debugging, but unless you're really into Visual Studio, it's not going to be any point talking about it today. Let's see. And then we've got Gizmos. So the Gizmos allow us to transform these objects. Transform is another word that I'm going to be using an awful lot today. Transform basically describes something's position, size, and orientation. And every game object has a transform up here. Now, because we're talking about 3D space, we have values for each of these components. So I've got a position, I've got a rotation, and I've got a scale. So I've got gizmos that allow me to modify the transforms of my objects, whether I can use their position, their rotation, or their scale. So I've got my cube selected, and I can see up here in this little graphic up in the corner, I've got three axes defined, an X, a Y, and a Z. So we're talking just standard Cartesian coordinate space. This is very much straightforward Newtonian sort of geometry that we're talking about here. No warp bubbles or polar coordinates, or there are quaternions, but we won't have to worry about those. And the color of the different axes correspond to these up here. So I've got a green arrow corresponding to the y-axis, a blue arrow corresponding to the z-axis, a red arrow corresponding to the x, and then on this view up here, the colored cones show me the positive direction, right? So the y-axis is pointing in that way, and then the green cone is sort of the direction of the positive y values. So I can have positive y and negative y values, you know, straight up Cartesian math. If I grab one of these gizmos, it's going to limit that motion. So I clicked on the z-axis, and now if I look over there on the transform on my inspector, only my z-axis values are changing. Then there's sort of a corner right there where I can drag in two different directions, and you see two of my arrows are highlighted, and my x values and my z values are changing. So it's staying, the y value is staying the same on that plane. And I've got different axes, different directions, different planes that I could grip this thing with. So that's my move gizmo. The rotate gizmo looks a little bit different. It's got spheres, and it shows me the angles that I'm grabbing this thing on. Now, you notice it highlighted that sort of equatorial line. If I grab that, just like grabbing the arrows on the move gizmo, it constrains the rotation just around that one axis. And then if I hold down the control key, it actually snaps my my rotation to I think 15 degrees. Or maybe 10 degrees. So that's my rotation. Then I've got a scale gizmo, and a lot like the move, I can highlight just one axis to scale this model up and down. Or I can grab this cube right in the center, and it scales along all three at the same time. Now, one gizmo, there's another gizmo over here that allows me to, depending on which way I'm looking at it, I can grab these grips and sort of stretch to fit a particular size. And then this is kind of a new gizmo that allows me to do rotation, scale, and move all with one sort of interface. So I can grab it around one of these lines and rotate it, or I can grab one of these arrows and move it, or I can scale it uniformly from the center, and I don't have to switch between different gizmos. So that's sort of a more flexible, somewhat advanced kind of option. And this is how you position things around the scene, how I want things set up. So let's say I want to build a room. I put a floor, stretch the floor out, I put the walls up. What's interesting about this is the actual mesh has not changed on this. It's still a 1 by 1 by 1 cube, but it's a 1 by 1 cube that has a different position. So it's take this 1 by 1 cube, move it to a position, rotate it around those angles, and then scale it differently in these directions. If I looked into the data of this actual object and looked at the mesh that defines that cube, the points and the value of those points, the location of those points in that model has been unchanged. You can think of the transform as what I'm doing to the object. I haven't changed anything about the object's geometric structure. I've just transformed it. All right. So gizmos are how I move things around. All right, and so this thing up here also shows me where I'm looking at my scene from. My game view shows me what my camera is seeing, but I can't interact with this. I can make changes over here in my hierarchy to what I'm seeing, and that'll be reflected. But if I want to move things around, or if I want to modify things, then I need to do it from this scene view. Now I can click on one of these and look at the scene directly down down that axis. So basically what it's doing is it's shifting my scene view to align with one of my major axes, and then that's the view that I'm seeing. So if I'm looking from the positive Y direction, this is what it looks like. If I want to look from the positive X direction, I can click on that over there. Now if I click on this cube in the middle, I toggle back and forth between an orthographic and a perspective view. The basic difference, basically this projection, all of my lines of sight are parallel. There's no foreshortening. Things that are closer to me are the same size as things that are farther away from me. Now this is very useful if I want to see how these objects are aligned with each other in just one particular plane. So if I want to make sure that, let's say I'm just going to create a sphere. So if I'm looking at this in a perspective view, it may be difficult for me to tell what exactly the relationship is between that sphere and that cube. But I can look at it from an orthographic perspective, and now I've got a much better sense of how these two objects relate to each other, at least in that one plane. And if I look at this from two different planes, if I wanted this to line up exactly with that cube, then I've sort of missed it because it's a little bit farther behind. So I can look down from the top, and I can look at it from the side. And using an ortho perspective sometimes is useful to line things up and make sure they're positioned exactly right. It really makes a difference if I've got two objects with large flat surfaces that I want to come together, and I want them to actually butt up with each other. If I'm looking at those two objects in a perspective view, there may be a gap that I won't notice. So if I want to make sure that they actually match up nicely, Grace is up here to get my attention about something, aren't you?
Yes. What devices could we use for testing with the VR thing, and where are they?
They're in a bag, or you're one of the Androids you can use. And you can build cardboard. I should build cardboard or Daydream or Gear VR.
Okay, thanks.
Okay. All right. Now, if I want to look at this from a different perspective than just these three angles, I can hold down the right mouse button, and you see how my cursor has sort of turned into that eyeball, and it's got, maybe hard to see, but it's got the cursor's got an eyeball and then four little squares. And I get that by holding down the right mouse key. So the eyeball now moves around and it changes my position, and the four little squares are telling you that I can use the WASD keys to navigate around through my scene. So I'm using the W, A, S, and D keys to sort of move my perspective, and it allows me to quickly position my view. So if I've got some work that needs to be done, like right here between these two objects, I can hold down my right key and I can use the WASD keys to actually move my scene view directly to something that'd be useful for me. The longer you hold the key down, the faster it'll go. So it may look like you're moving really slow, especially if I have a long distance I need to travel, but it'll constantly accelerate, and pretty soon you'll get to a point where you're moving way too fast and your scene view's way out in the middle of nowhere. And if that ever happens and you can't find your objects, a lot of times you just won't be able to find them. You look at these numbers over here and they're all just crazy. If I double click on any of these, then my camera view will zoom to center that object and make it nicely visible. So I could be way out here. And I'm just going to go so far out, all this stuff even just disappears out of my camera view. Yeah, I'm so far away, I have I can't see anything. I don't even see the grid anymore. I don't see the gizmos. I don't see anything. But it'll take me right to that sphere. All right. So, talked a little bit about what game objects were, talking about the components of those game objects. You can have multiple different components on a game object that define what it does. So, say I've got this sphere here. The transform is a component of the game object. All game objects have a transform, and in fact, it's the only thing that all game objects have. Because I could have an empty game object that represents just a position in space. Maybe I want to spawn something in there, or maybe I want to keep it as a reference. But if all it does is just sit there, it still has a transform. Now, I've got different components under this game object that sort of define its sphereness. I've got a mesh filter, which is the actual geometry. It's the actual vertices and the actual polygons and faces that make up this surface, is here in the mesh filter. Then I've got a mesh renderer that sort of determines how it interacts with the lights. Where does it get its shadows from? Does it receive shadows? Does it cast shadows? What kind of shadows? What kind of materials does it have with it? Maybe it's got multiple materials on it. So there's a list of materials in the mesh renderer, and there's all sorts of, and then the sphere comes with a sphere collider. Now, I didn't tell it to put a sphere collider on it, but when I make a primitive sphere in Unity, it's going to attach this collider to it. A collider is what sort of gives an object access to the physics engine. So the physics engine does things like checking to see if things have intersected with things. It checks to see if rays will have hit an object. So if, let's say I'm shooting, boom, I shoot my simulated gun. My simulated gun uses Unity's physics engine to cast a ray out the front of that gun. If it hits a collider, then my game knows that I've hit at least a collider. But an object has to have a collider on it before it can start interacting. Before it can be solid like a floor, or fall like a brick, or be shot and pop like a balloon, it has to have a collider on it. Probably has to have more than just a collider, but the collider is the basic sort of thing that adds access to the physics engine. Then this sphere has the default material assigned to it, but if I had assigned a different material to it to give it a different look, the material would also be a different type of component to it. And then behaviors are also components. So if I want to pass data from one behavior into another, I have to have a handle to the game object, and then I have to go down inside the game object and find that component that I want to talk to. And it's not all that scary sounding. But you just have to kind of keep your head wrapped around the game object. Everything is a game object. Every game object has a transform, and then I add other components to that game object to sort of, like Mr. Potato Head, build whatever I want to build. You know, put his angry eyes on him and give him a potato skin color. Okay, so much for that PowerPoint slide.